All right, so in the previous video, what we did was we had a scatter plot, and then using Microsoft Excel, we figured out what this least square line is. And then based on this line, we tried to predict the price of the handbag in 2020. So just a word of caution here. Please take note that strong correlation does not suggest that X causes Y or Y causes X. What this means is correlation does not imply causation. What are we trying to say here? So for example, there is a strong positive correlation between, let's say, your air conditioning bill and crime rates, meaning as the bill increases, so do crime rates. Now, does this mean that if you turn off your air conditioner, it will cause the crime rate to drop, right? Does turning off your air conditioning cause the crime rate to drop? So obviously the answer here is no, right? Obviously not. But in this case, we have what we call your lurking variables, so which are both related to X and Y. In this example, a lurking variable could be air temperature. So as the air temperature increases, both crime rates and air conditioning bill also increases. So usually this happens during the summer, and I'm pretty sure you can understand that, right? All right, so remember in the previous video, instead of the correlation coefficient R, what we had was R squared. Now, what is this R squared? This R squared is called your coefficient of determination, right? So the small letter R, or the correlation coefficient, tells us if there is a strong positive or negative relationship between the two variables. R squared, on the other hand, which we usually state in percent form, is an interpretation in the context of the data. So it represents the percent of variation in the dependent variable, which is your letter R, right? Letter Y, that can be explained by variation in the independent variable, which is your letter X, using the regression line. So it looks complicated when we say it in words, but let's go back to also. Another thing is 1 minus R squared. Okay, sorry about that, R squared, right? 1 minus R squared, when expressed as a percentage, represents the percent of variation in Y that is not explained by variation in X using the regression line, right? So what does this mean, right? It looks very complicated when we say it in words or when we read it in words, but let's go back to our previous example where we had a graph for the price of a handbag, right? So our R squared is 0.9673, right? So I will round it up to 97%. So what this means is 97% of the variation or the change in the price of the handbag is explained by the number of years, right? Or letter X. So the remaining 3%, right? So 1 minus R squared, or 1 minus 0.97 is equal to 3%. So this is explained by some other variables. So it could be the materials, for example. It could be the quality of the handbag. It could be labor and some other things that could affect the price. But what this is saying, this R squared right here, what it's saying is that 97% of the variation and change in the price of the handbag is explained by the years here, right? So obviously not 100% because the line does not pass through all the points in our scatter diagram. All right, now let's go back to our sales rate, right? So in the beginning, I showed you the data, right? So maybe you can do it on your own. Try putting the numbers on Excel and make sure that you understand how to do linear regression. And after doing the linear regression, I came up with these numbers right here, right? So you would want to try that as well. So as you can see here, the least square line, right? So I use 4 decimal places, or at least this is automatic on my version of Excel. So it says negative 0.0032x plus 1.5958, right? So that's my line right here. Okay. Now the correlation coefficient R, if I were to calculate that, would be the square root of this, right? So this time I'm going to put a negative before, and the reason for that is because the line is decreasing, right? So the slope is negative. So now I used my calculator and I calculated the square root of 0.8109 and I came up with negative 0.90, right? So, or negative 90%. So what does this mean? Usually if you have a correlation coefficient R, which is 90% and above, right, we say there's a strong correlation, right? So in this case, there is a strong evidence of association between the two variables, but this time instead of negative association, instead of positive association, it's negative association, right? Because the line is going down. So in terms of the R squared right here, in terms of that R squared right here, right, this means that 81% of the variation in the sales rate Y is explained by the variation in the price X, right? So what is the remaining number, right? So you want to go up to 100%. So 100% minus 81% will give you 19%. So meaning there is still 19% that is explained by some other variables, right? So can you think of some other things that can affect the sales rate, right, of the handbag, right? Can you think of other variables that you can measure, right? That has to be quantitative, that can affect the sales rate, right? So because you still have that remaining 19% there that's unexplained. All right, so this time, predict the sales rate if the price is $420, right? So in this example, again, X here, right? This X right here, or your horizontal axis is the price. And then here, your Y, right, is your sales rate. So this letter X now, since I want to know the sales rate, this letter X now. Okay, sorry about that, class. So for 20, I wrote initially 500 here. So the sales, we want to know the sales rate if the price is 420. So then using your calculator, it comes out to 0.2518, or approximately 25% is the sales rate. All right. Thank you so much for watching. If you have any questions, please make sure to let me know.